Maksim Viharev, Technical Director of Analytics Company. The report is about GreenHouseSQL. Hello everyone. I'm very happy to have people the last day, last presentation in this room. This is great. I hope it will not be too boring. I tried. And I hope you'll get something useful for yourself. Let's start. The theme of my presentation is GreenHouseSQL, scaling system of analytics for postgresql, greenplum, and clickhou. So in the very beginning, I want to introduce myself. My name is Maksim Viharev. I'm the co-founder of Analytics company. I'm a data engineer, software engineer, and release DBA engineer. Someone asked me, what do you do better? But not the photos from the phone for sure. In the beginning, let me tell you what we do. Analytics is the system of analytics. It's been 1.5 years we've been working on the system of analytics in internet marketing sphere. We also call it the system of threat analytics. Who purchased the tickets for the conference themselves? And who learned about the conference through email or Facebook or internet? There are such people. So let me tell you what we precisely do on an example. For instance, there is a conference, there is a budget for advertisement, the marketing have the of analytics that calculates the visits, for instance, and sets up the information on different platforms and distributes the budgets between those paths. So we see the advertisement, for instance, you go to this website and you visit the forums, you make a query for the ticket, and then you purchase the ticket, and this fact of purchasing the ticket is being written in CRM, and so the organizers see how many tickets have been purchased, have been sold, and they know exactly how many tickets have been sold, but they do not know what's the profit that they gain. And the marketing sets up the analytics, has the connection to all the platforms into analytics system, and then the data for the commercial content, the costs for the content, the sessions on the sites, the targets, the goals, and the sales. All the information goes to analytics. Analytics combines all this information, compiles this information using tracking methods, and then they ask a question like, what traffic brings more profit? So it's able to answer this question. So analytics is represented in the graphics, tables, and interactive BI. You can load it in this as CSV, PDF. You can upload it for the planning according to the schedule and automatization. So this is how the budget's being distributed between these systems. So there's some vivid peculiarities that played a big role during all the steps of this in this process. So first of all, we have the talkings. 3 times a day we start up with a distributed system of workers that for each project individually it goes to the external server, takes the data and brings it into the database. We have many projects, few thousands of projects, and this is a very specific thing, which is focused on different clients. The second, that the pane that we have is regular retrospective corrections. With the stats, we do not append only. The thing is that on a regular basis, the clients and the systems, they make some corrections, and they expect this targeting from the previous data will be updated with the new data, but we are limited by IPs that can be broken, that can be limited, and we need to get the old data. This is a big problem in the analytical system, and this is a key pain that influences the whole realization that I'm going to talk about a bit later. Next fact is that the structure is not coherent. All the data that we receive from different sources is not similar. For instance, the data for the costs. In Yandex Direct, this could be different tables with different structures. And Google Analytics, we are limited with API, and we can take 5 measurements, and we need different cross sections. So basically, we need to aggregate these hoops and put them into a database, and with different evidence, we need to ask for the query. This makes our life difficult. And of course, we have huge projects. The biggest case is that we have Hof company, price with millions of different words that we need to analyze. The biggest project, the monolith systems, they just come and they just everything just becomes flat, like everything lays, just fails. And as for the transport effects, the goals that we want to see in our final report by the client, there are different reports and different projects. This again makes our life harder because we need to transform them into something that the client expects to see. So this is not just a flat table, lots of different joins, transformations, and also we update content on an everyday basis. So we upload the data, and we want these upgrades to be shown in the reports. Synchronization of statistics is performed three times per day, and plus the deep upgrading, especially if in old data something's changed, like clients changed something half a year ago and sees the new updates. Maybe someone were here in 2018 when I gave the presentations on PGConf. So shortlist, nobody was. Okay, shortlist speaking, I talked about the Postgres with the alarm, ETL, and we decided to divide it through the logical replication. The content was kept on TP, and the statistics in val, and through ETL we poured the data of LTP and interface applications or envelop by the final queries. This is monolith alarm.
And so it worked, but it had some problems related to the whole OLAP Postgres. As a matter of fact, there was the subsidence in the speed at longer periods and deeper periods, despite the sectioning which we used already at that time. Still, we had significant problems, and big projects on the monolithic server were affected also others. In the monolith Postgres, and with big number of sections, we had very long, unbearably long migration of data. And to add the table and to add column and to place something there, it was too long. We had a case when we realized to add an ID project, and since the OLAP was active with active users, we could affect it only at a certain period of time or do it partially. It took us 2 months. And going a little bit ahead, now in greenplum we can do it in 15 minutes. And that was a real problem. Complicated failover, taking into account the logical replication, which was based on Ladist. Such tool, have you ever used this tool? Someone of you? Yeah, you know that in principle it's a stable thing, but if something is off, it's really difficult to switch over to another client. One way of vertical scaling, if you want speed, buy a new server. I don't remember how many projects of which we did, but that's a deadlock. A special peculiarity, individual processing project by project, and to make it work on the top level and quickly, we had to build individual aggregates. It was a separate pain for every project, and we had thousands of projects, and we had to face serious limitations, and we couldn't develop properly. And also, a problem of Landist was related to the fact that if something big is in the output, Landist is not able to cut it into pieces. It starts to replicate it all. If a big client comes and changes something, there is a delay of several hours. And I would describe PostgresQL situation with such a picture. I don't know whether it's good here or not. With time, by mid-2017, business decided to transform it to the analytical system, and before we supported only a few channels, and in all fronts we faced limitations of monolith all up, and we had to do something. We decided to formulate requirements to the system we would like to implement. First, we wanted to take the top level, where for the user should be opened for less than 1 second. In milliseconds, user comes and immediately gets it opened. On detail levels, we wanted to reach Google Analytics speed, around 10 seconds in every pre-reads, independent of the depth. In our plans, we also have to support all traffics. We expected new services, new data, and this system had to withstand these volumes. We also had in our plans to install multi-channel analytics. I'm a little bit limited in time, but please believe me, this is a very complicated form of ETL, which allows it's not possible, and it's quite complicated to realize it without Windows functions. We really needed Windows functions to implement complicated and comprehensive ETL to make it possible to rate all data. We wanted to do it all without bloating our stack, since we were in the state of a startup. We had the spirit of a startup, we had a team, we had a stack, we wrote on Python, we had PostgresQL, microservices, and roughly speaking, we were not able to dive into unknown in the form of other stacks, different stacks. In the perfect case, we wanted to have a backward compatibility with old applications. It was SQL, we had legacy systems, CTE, different joins, transponding, multipliers, all that should have continued to work without changes. We had to have minimum latency for the content. Looking around, we saw typical DWH solutions architecture, the same the concept of a data lake, of a joint storage containing everything. Everything is delivered there. Using different mechanisms of change capture mechanisms. On top of that, there is ETL, which combines everything, prepares open windows, and then it's all going to be uploaded to the column-like storage systems. As of quarter 4 2017, we had the following options how to implement it. First, sharding of application level was an option to take the OLAP, to split it manually into pieces and use it and use it somehow. Well, this is the concept, as far as I understand, is used in Postgres master multi-master, professional Postgres multi-master. We made a test stand and we understood that we need to double all systemic components. We have to reinvent the wheel which is going to orchestrate it all, and so we got rid of this approach. The second system which we considered was PostgresqL XC. Not the bad system, but without embedded partitioning, so we were not able to download our data to it. The third system was clickhou, which broke into the community. It was a buzzword, everyone loved it, but we had to need a normal ETL. We checked clickhous, there were no normal joins, so we thought we won't be able to build multi-streaming on this basis. It's really good for local solutions. Next option, PG shard from Citus. Do you know it was bought by Microsoft, by the way? And greenplum. In Citus, there were no rebalancing. It was not possible to quickly restore something which was broken. But when we looked at greenplum, we were fascinated. Only looking at the documentation, we understood that we will have everything we need to solve our issues, especially using greenplum. On top, I show you the links, and you will also see it later. This is a very useful information, everything what you need to start working. greenplum has sharding. Previous speaker told us in brief, we set up a cluster, we indicate the number of shards, we create a table, distributed field, everything is being scattered around across the shards out of the box. Next comes partitioning, everything is needed, everything is easy without any special sophisticated operations, different type of storage, heap, doubling of Postgres, append only, append optimize engines, takes the file, compresses it in our cases after populating, and we had a compression by 10 times. We didn't expect it, that we have such a reserve. Real column-based storage in conjunction with compression gives a wonderful result. INC SQL with window functions, everything which is really needed, and it really works. High availability out of the box, sharding of all the segments, you can give a scale factor to all of them, mirrors can be deployed at adjacent nodes, and if one node drops, it deducts it, redistributes it in an active way, and it all continues to work. Which is nowhere else is MPP data uploading. A little bit later about that, but of all sources we can aggressively upload it in parallel. It means that all segments will come into the source in parallel and will download according to the capacities of the network. It allows to make pipelines with minimum latency. It's very pleasant that greenplum with Pivotal company, they are compatible with the latest Postgres, JSON, HStore, working out of the box in version 6. They want to use it for version 9. They already have the alpha version, and they already on that. I attended a conference with the overview of Pivotal. As far as I understand, there are 200 developers, and they are important and committing all these things from Postgres to greenplum. What it is all open source, which is also free of charge, very pleasant. You can set it all up and install and use. So as I already told you, we started to try systems with a pilot, and the pilot cycle which we created on greenplum, we ran it several times. We set it all up, we downloaded all data, we tested performance, we recharged it. It is done by one command, by the way, in greenplum. I'll show you later how can be done. Then we updated the data structure, changed the configuration, and did it once again. And we made a few cycles, and as a result, we developed our concept, and we outlined key points, key bullet points. First, download from Postgres to greenplum. Greenplum has a wonderful mechanism, external table. It allows you to download. You create a table, you indicate the source. It can be a file, S3 storage, or even a script, which is located on the master node. These are soft type ways to test. The real way, industrial ways, is GPFDist and PXF. GPFDist is the way we selected. PXF is a thing which is more universal, it's scalable, and maybe if you decide to do something now, try PXF, but GPFDist, you will see what is this. In brief, this is the picture describing the whole architecture, and the main point is that the server with the data source receives files, and web server is started on this source supporting a special protocol. This protocol has a feature that when all segments start to come to GPFDist, it gives away one by one a piece of the piece file, and so everybody downloads the whole file in parallel. Then inside the greenplum, this file is being moved according to the sharding rule which was selected, and as a result we get the download speed equal to the speed of the whole network. Just to confirm, you can download it from Postgres. We start such command from the server, from the base, 8080 port, and then it opens the server and looks at GPFDist directory. In Postgres, we start a command which exports the file to the certain table, and we create external table in greenplum. Then we insert into the target from external, and we get the ready-made table. A small hint for you. Well, the system is cool, and in our case it's a really cool story that OLAP was almost full, and we were not able to upload this big table because we faced a lack of space, of disk space. It's a cool hub also to use the file pipe. We write there. You can even zip it. GPFDist compatible with and supports zip, and so file will have compression and will in parallel be downloaded to the greenplum. It's all easy as a result. Factors which affected the speed of operation of our samples. Whatever we ran or tried, the most important is the relational scheme. We had an additional denormalizing which speeded up the whole system. We took additional joins and everything was up and running very fast. This fact was a cause for ETL processes. After we uploaded everything to greenplum and incrementedly downloaded it, we received it all there. But a little bit later on that. The relational scheme means less joins, and this is better. Join based on the sharding key is the best practice. If something is not clear, explain, show you the plan and the link how to analyze it. Sharding out of the box, but sharding MPP. You should understand that MPP sharding means that greenplum MPP sharding is a sharding when you have to shard it based on the minimum content to spread data across the whole cluster. First, we thought that let's shard it by client, let clients be a basis. But as a result, the biggest client, everything is stuck on this node. The global planner of greenplum builds the query to maximize the utilization of the whole cluster. If something's stuck on one big node, one node stops and it doesn't work. The correct pattern, according to our practice, is to shard based on the minimum key. And in this way, to make joins local, to make this minimum key to be used also with the joins. Even if it's not possible, greenplum can redistribute everything inside. You will just tell him select. Select will work. How it will work, it depends on all these factors. A very important fact, the data skew. Even if you made a correct sharding, a very scary situation which we faced after 1 year, we had some data where one key is an empty line, and in the sharding key, in the sharding field, one empty line appeared. It went to one node was overloaded, everything stuck with one node. It's very painful. You can follow up with using this simple query. In partitioning, everything is really simple out of the box. The storage type is heap for often updated data. Time series for statistics is append-only plus compression. And in some cases, tests should be done on queries and where really needed. There is a myth that indices are not needed in greenplum, where you have cases with smaller clients and with hint blitzes. Still, you need it. You should measure it and you should test it. Here's a small prompt on significant configuration options. First, optimizer is cool. Pivotal company does their own optimizer, GP Orca. They have two planners, GP Orca and Legacy. Optimizer enables GP Orca, and all queries should go faster. In our case, the optimizer slowed it all down, and optimizer off speeded it up. Next important option, statement mem, is the number of memory for every query set by session. Well, everything is quite easy, and we also heard auto vacuum is off. We learned about it a little bit later when everything was finished, and for PG catalog also. This is important. As a result, we automated auto vacuum of PG catalog. In the maintenance was embedded in the application which switches everything. We measured everything. We understood the factors of sharding, acceleration, what should be done, what should be added, and now the question is how to integrate it all in the existing system. We understood that we need to reload historical data. Facts, statistics should be reloaded. Next, we should reload the content and changes in the content. We need to have an opportunity of incremental and full resync And for the full resync, we wanted to use any databases. So the case when in VolTP we delete something, we restore the backup, we reset reload for backup, and we incrementally add lost data. We used it several times.
Next requirement was the necessity of having more simplified integration to the applications with existing interface, with requirements, with queries, with no changes to be integrated, and just a full compatibility. But we were ready for a minimum changes, the blockers that are pulling all the time. Also, as I've said before, we understood that we need additional processing of the data when we uploaded them, serialization, that the queries were maximum act, and also to make the automated operations so that DPA would not appear. Everything was automated, and we wanted to keep it that way. So we took the coding system and the pilot and put it into applications. The first application, ETL GP, which is the applications with its own number of daemons. In this application, we make the description of configuration of the tables and resources bases. It has the command interface in order to create the tables and full synchronization of certain tables. Later on, we had in scripted Python framework for the organization of ETL pipeliners and posters that we already poured. And next one is the microservice integration, PSQL importer. It's a provision together with any base and provides API for the exporting data to the file system in folder gpfdist. So this is a simple thing that does FIFA through API. Exports SQL to the file, and this file can be deleted afterwards. This compilation of these two components is the following. First, it is deployed PSQL exporter to the resource database, and based on that, we have two ETL GP and PSQL exporter. Two applications are brought up, and you can use that with a description of configuration of the resources of the database in ETLP, and configuration description of the table, and then we start the command with full synchronization of the tables. This is one of the instruments that allowed us to quickly upload information. Then we needed the realization of how to monitor the changes in the content and check the cost, but we need to increase the stack, so we needed some logic so that would pour it to greenplum, and so we used the trigger SQL mechanism in order to monitor the changes, and that was implemented by the command etlgp in the resource base, and that triggered all of the changes in the table, and then the phone process in a cycle would be loaded to the database. This was the most stable decision that is still running and keeps up with the load. Following the changes in the time partition, it was a bit difficult because we had a system with phones processes. We would put everything in the database, and we added such thing like informing ETLGP about some data for certain projects that have been changed. Team and ETLGP would get this information and would start up, would gather and retrieve from metabase all the data that's been changed, and would go to the base and would increment it from that database. ETL processes there was a possibility after the update to start up the table in ETL process. And some of the agreements and the basic ones that we had for one table in one process for each table. And the key topic that has to do with upgrade, I only have 3 minutes left. I do not even know what to do. Can we sacrifice with questions and answers for me to finish the presentation? What do you think? Yes, let me speak up faster. So, because this topic is interesting, the update of without the downtime of ATL where M is maintenance. So taking into account the algorithm of correction, we need to update the old data, taking into consideration the additional realization of uploaded data and encrypted needed vacuum, vacuum. The procedure of the walker starts up the project, the upgrade of the project. It informs the chunks DTLKP that some of the projects have changed. ETLGP generates SQL and addresses to exporter. Please upload this table for this type of projects for these specific dates into the files. This file is accessible for GPU disk, and in greenplum we make external table which looks at this file with segment, and then we do delete and from the target table for the specific project and specific dates, and we upload this incremented data. Then, the date that we already know, we see the partitions that have changed in the target table with the following methods, and then for this sections we do vacuum analyze, and we receive the ready data with the correct statistics in the end. In the previous slide, I've mentioned everything that according to our agreement in the public scheme we got the lack and the data that we upload with it, the applications do not run. The applications only run with the tables and service schemes. So here in the public data wave we uploaded the data through delete, insert, increment, and made the vacuum analyze of this blot, and everything was fine. Then the procedure of the additional transformation is uploaded for enrichment from this previous section. The initial section, it enriches it with all necessary attributes, and as a result we get the temporary in template, and then we do the analyze, and we analyze that, and then the final service scheme through the exchange partition. We have the final service scheme that is enriched with the data, and they are sectioned and classified, and we put this increment to the public, and we see what section has changed. We enriched it, we rebuilt it, and updated it in this final service scheme. So this thing without the downtime helps us to actualize some sections in the final service schemes. As a result, this application goes to the service table and the service scheme, and it's not being affected with any analyzers, and it doesn't see that that something has changed. So this is incremental update. How do we monitor and control? First of all, we have the general plan, which is done by GP state. This is the command that brings the zeros and everything's okay. And one when it's not okay. If it's not okay, that something failed from the code, and this step procedure of the failover is being active. So we do not have reliable hosting. Unfortunately, some of the inputs fell off. It keeps on working, and if we add a new server, we add it to the cluster, 3 commands, and everything's running. In one case, the commutator fell off, and the whole cluster fell apart, and we thought this is the end. But fortunately, we provided these 3 commands, and everything worked fine. So this is the best thing that happened to me, apart from my wife, of course. So all the lags for pouring and loading and ETL processes on the upper level, they're being controlled in Grafana with a certain triggers, and we see all the delays as something is increasing, growing, then they trigger. Then we use the health checks for all ETL GPE on all the stacks that we have on the configurations. Health check is checking, goes to the base, creates the table, exports this table through to the list to greenplum, and pours it in and checks the data. It's done every 5 minutes, so if we lose something, we react. Also, we have admin on the chunks to see if it's been uploaded for some of the projects or did not. And we also have API readiness of the pipelines and individual chunks for outside sources. Final profit, everything is done in 10 seconds, doesn't matter which project is that, doesn't matter which period it is, it's only 10 seconds, takes only 10 seconds. The positive profit is in the following: we took the aggregate and some nights upgrade, so it took us 1 hour or 1 hour and a half, and everything was set up. One of the case, we have a VIP client with lots of content, and we had some individual analytical backlog with 500 TPCH, and it took 12 hours, and now in general cluster it takes only half an hour. And then compression, 7-10 times lab compressed, taken into account that we doubled and tripled everything with all these schemes, and this is great, extremely. And then the backup is very good. The myths about the hardware. In this context, I would say that the name of this presentation would be when we did the vertical scale instead of 2 top DL, and with great disks and great memory. Take 14 cheap no-name hardware and you would get the profit anyways. This is a real fact. So we can build up DVH with a really bad, the cheapest hardware, and this would be the cheapest way and would be the most reliable way with debian. And the second myth about the documentation of greenplum, we need the network version 10. We have 1 gigabit and everything runs fine. And maybe for some it will be shocking, but our rate is 0. Nobody just shout, oh. But no doubling, no copying, SSD, it's mirroring inside of the greenplum. If something falls off, recovery SAC is working just fine. And we have some disadvantages. Everything is done only in 10 seconds. On the upper level, we wanted to have like a milliseconds, but greenplum with its own global optimizer, with this optimization, it takes 1.5 seconds, and the joins. We needed to have a fast layer, the fastest layer, but only the methods of how to build up fast and quick queries. And DVH, Ralph said in his book in 2008 that the models of the queries should not contain more than 1 connection, so to make it fast. But he didn't expect that the modern prices for the hardware and memory will decrease so much that will be make this flat tables and take all these facts and put it all together, compile it, and provide an API for them. And this is extremely fast. In greenplum, because of the global planner, it doesn't work that well. It takes seconds, and for the planning, and also the transporting the facts in a flat table. It's not possible because every project has its own columns, the number of columns, the number of goals. So in the normal way, it's hard to create the query. Clickhouse, internal sharding, then the planner is sharpened for local data, so the query goes and effectively done practically by one node in memory. If we are scaling, shading it in a good way, sharding it in a good way, everything will be fitted in one memory. Then we have encrypted structured goal, in-house encrypted. It covers the difficulties that we have with flat tables, plus in-house multi-master, merge engine, tables for the upgrading, and we have the general architecture that looks just like that. Parallel to the workers with loaded from the cloud and from external services, the data, compile them and post them in Postgres, and then informs ETL-GP, it pours out back to greenplum and processes it in array and all the data from the client with only one query. It goes just like that, processes the information, builds up a flat tables with pouring out the data to the clickhouse, and from the clickhouse everything is shading by milliseconds. It's great. So the final profits, it's 10 seconds for detailed data, including all the levels, less than 1 second the level for compiling and PI, quick MPP, fast MPP, ETL layer with NSSQL and window functions, and in memory fast layer of the data without rewriting the applications and the delay of the content. Thank you very much. Very useful links for those who are interested in open source of this exporter and ETL-GP. We are planning to force it. We also have greenplum group and the group that helps you to answer the questions, and this community, Russian community. You know that there is a group for Russian community for ClickHouse, and please come and follow this link. We're on Telegraph. We'll have more greenplum information if you're interested. Questions? Thank you very much, Maksim. Please raise your hands. Thank you for your presentation. I have a question. How do you pour out the data with a tone upgrade? The existing scheme starts from 0. The full upgrade, first of all, make a stop in the pipeline, then we pour the data into the table next to it, and then in transaction we drop out and commit. So it's next to it. It's very close. Yes, it's very close. We do the exchange partition. Statistics. We do not pour it completely, and if we pour it, we do it chunks, partially through quick exchange heap tables, content. We build up and fully pour them through alter rename tool. Not through the exchange, but we rename it. We drop the old one and make the new one. With a small delay, with a small downtime, but still, it's a rare thing. I don't remember the last time we did that. Did I answer a question? Yes. Thank you for your presentation. What is the volume of data in greenplum, the number of messages? Less than 10 terabytes. No, the lines, the number of lines. I don't know. Billions, I think. In wraparound in Postgres, have you used that one? Yes, we use the triggers, and we need to make them. Thank you.
Пожалуйста, еще вопросы?
More questions, please. About wraparound, it's a very interesting topic. To pause everything and make it in parallel, the only way. The back row, I remember you wanted to ask something or comment. Not Windows functions, but window functions. That's the only remark. Here, please. You said that about indexes, they should be used with heat tables. How do you control optimizer? How can you strive? Can you fight optimizers who don't want to use it? We do not fight them. We don't. As far as I remember, greenplum in the settings, the random cost page 100 almost always uses full scan and table scan. Maybe in our cases has a difference that we analyze all the time after something's changed. We press on analyze, and statistics is quite good. Well, in the queries where we use heap and where we have this spotted sampling, there maybe index was used, but for some reason it was not skipped. In my case, Castle E used such very quite bad queries with switched off optimizer. Only in this way it was used in my case. Thank you for your presentation. How do you plan to route your queries between greenplum and greenhouse? We have different functionality. In clickhou, we have the so-called high level and dashboard level. That was all which was done within the new positioning and new functionality. And what was before, it still belongs to greenplum. We split it, we distinguish it between new functionality and old functionality, and applications know where to go. Thank you for your questions. Thank you all.